all. Today we have to discuss about heat of neutralization or enthalpy of neutralization. What is the heat of neutralization or enthalpy of neutralization? The heat energy released or evolved when 1 gram equivalent of acid neutralized by 1 gram equivalent of base in dilute solution is called heat of neutralization. So here 1 gram equivalent of EQ means equivalent. 1 gram equivalent of acid neutralized by 1 gram equivalent of base. 1 gram equivalent of base in dilute solution. So, heat of neutralization is always exothermic process, because already we know when the acid react with base, salt and water formation, okay, there more heat energy evolved or released. That's why heat of neutralization process is exothermic process. This is exothermic process. Okay, so best example, acid plus base neutralized, salt plus water, del H equal to minus X. Okay, del H equal to minus X heat energy released. For example, HCl plus NaOH gives rise salt, NaCl plus water. So del H equal to minus X kilojoules for equivalent or kilocalories for equivalent heat energy released. Okay, so here when the one acid react with base or one acid neutralized by base undergoing to neutralization, your heat energy release remains constant. Heat energy released remains constant. Okay, that means, for example, 1 gram equivalent of acid neutralized by base, it gives salt plus water. Already we know so here heat energy released remains constant for 1 gram equivalent of acid neutralized by 1 gram equivalent of base. So what is that value? Case 1, the constant value, strong acid, SA means strong acid, plus strong base, strong acid plus strong base undergoing to neutralization, salt plus water. So 1 gram equivalent here, 1 equivalent of strong acid, 1 equivalent of strong base, 1 equivalent of strong acid neutralized by 1 equivalent of strong base. How much heat energy release? So this value has remains constant. That value del H equal to minus 13.7 kilocalories for equivalent. Okay, or del H equal to minus 57.2 kilojoules per equivalent. Okay, so any acid or any base, any acid, any base, but strong acids. Okay, any gram equivalent of strong acid and 1 gram equivalent of strong base undergoing to neutralization, the energy has released is in kilocalories minus 13.7, in kilojoules minus 57.2. So this constant value applicable for any gram equivalent of strong acid neutralized with gram equivalent of 1 gram equivalent of strong acid with 1 gram equivalent of strong base. Okay. Next, case 2. Case 2, weak acid, weak base. For example, case 2, weak acid, double A means weak acid, weak base, salt plus water. So here, one equivalent of, EQ means equivalent of, one equivalent of weak acid neutralized with one equivalent of weak base. How much heat energy released? So here also constant values is there, that is del H equal to less than minus 13.7 kilocalories per equivalent, then del H equal to less than minus 57.2 kilojoules per equivalent. Why does for weak acid and weak base heat energy released less than strong acid and strong base? So weak acid, weak base, some heat energy used for dissociation of their bonds, because strong acid, strong base fastly undergoing to dissociation. So strong acid, strong base completely dissociation and fastly, but weak acid, weak base incompletely dissociation, and dissociation process also somewhat slow. That's why some energy useful for dissociation takes place in weak acid and weak base. That's why weak acid, weak base heat energy released less than heat energy released for strong acid and strong base. Okay. Here first of all, what is the equivalent? So you should know in formula, equivalent equal to number of moles into, this is very important, number of moles into valency factor. So equivalent equal to number of moles into valency factor. So valency factor based on the acidity and basicity of acids and bases. So number of moles no problem, you can easily find out, but valency factor you should knowing, okay, for proper acid and base. Okay, this is the formula, equivalent equal to number of moles into valency factor. Okay, already knows for acids basicity of acids. What is the basicity of acids? That means basicity of acids means it can able to release of H plus ions. So basicity of acids means it can able to release of H plus ions, protons. Okay, so for example, monobasic acids, that means only one H plus ion release, only acid, so only one H plus ion release. That's why valency equal to 1. Okay, examples: HCl, acetic acid, CH3COOH, HNO3, nitric acid. Okay, next, dibasic acid. Dibasic acids. Dibasic acids means it can able to two protons release. That means two H plus ions producing or two H plus ions has release. So here two H plus ions release. Two H plus ions release. Okay, here dibasic acids valency equal to 2. Okay, valency equal to 2. Examples: H2SO4, sulfuric acid. So sulfuric acid is the dibasic acid. So it produce 2 H plus ions, 2 H plus plus SO4, 2 minus. So H2SO4 is dibasic acid. So H2SO4 valency we consider as a 2. Okay, next one. Acidity of base. Acidity of base. Acidity of bases. Acidity of bases. Okay. What is the acidity of bases means? Bases can produce OH minus ions or bases has released OH minus ions. Okay, for example, mono acidity of bases. Mono acidity of base. Only one OH minus ion producing. One OH minus ion producing. Examples: NaOH, KOH. NaOH and KOH. Next, diacidity of base. Diacidity of base. That means here two OH minus ions producing. So two OH minus ions producing. Okay. Examples: MgOH2 or beryllium hydroxide or calcium hydroxide, like that. Here two OH minus ions producing. Otherwise, triacidity of base. Triacidity of base. 3 OH minus ions producing. 3 OH minus ions producing. Okay. So examples: ALOH trice, like that. ALOH trice. So this is the acidity of bases. So you should know in valency. Otherwise you can't solve the problem. You should know in basicity of acid. You should know the acidity of base. That only you can easily solve the sum. Okay. Next one. Very important one. Very equivalent of acid equal to 1 gram equivalent of base. So here important one, 1 gram equivalent of 1 gram equivalent of acid equal to 1 gram equivalent of base. 1 gram equivalent of base. 1 gram equivalent of base. Okay. Important formula. So 1 gram equivalent of acid equal to 1 gram equivalent of base. This one you should remember. Next one, equivalent equal to number of moles into valency factor. These two concepts you should remember. Formulas are concepts. Okay. For example, 1 equivalent of HCl plus 1 equivalent of NaOH gives rise NaOH gives rise salt plus water. Okay, here del H equal to minus 57.22 kilojoules per equivalent or minus 13.7 kilocalories per equivalence. Okay, next 1 equivalent of H2SO4 plus 1 equivalent of H2SO4 plus 1 equivalent of MgOH twice, for suppose MgOH twice. Okay, gives salt plus water. Here salt plus water. Okay, here also del H equal to minus 57.22 kilojoules per equivalent or minus 13.7 kilocalories per equivalent. So 1 gram equivalent of acid equal to 1 gram equivalent of base. Okay, now just examples these are. Now we have to solve the problems. So problems can solve only you can understand easily. Okay. So in today's paper, today your paper only given questions. 1 mole of H2SO4, 1 mole of H2SO4 mixed with 1 mole of H2SO4 mixed with 2 moles of NaOH. 2 moles of NaOH. 2 moles of NaOH. The heat evolved is. Okay. So this question in yesterday your question paper. Okay. Listen. What I say here, H2SO4 is strong acid. H2SO4 is strong acid. NaOH is a strong base. Okay. What I say, 1 gram equivalent of acid equal to 1 gram equivalent of base. So here 1 gram equivalent of 1 gram equivalent of acid equal to 1 gram equivalent of base. 1 gram equivalent of factor. So a gram equivalent of acid means nothing but R number of moles into valency factor. Okay, equal to here also gram equivalent of base means number of moles into valency factor. Formula very very important amma. Gram equivalent means number of moles into valency factor. Acid means H2SO4. How many moles? 1 mole into what is the valency factor of H2SO4? Before only we discussed. H2SO4 is dibasic acid. H2SO4 is dibasic acid. That's why H2SO4 valency factor 2. 1 into 2 equal to 2. So 2 means what? 2 gram equivalents. 2 gram equivalents. 2 gram equivalents. Okay. Well, here you find out here 1 gram equivalent of base. How many moles of NaOH? 2 moles. 2 into number of moles 2. 2 into what is the NaOH valency factor? NaOH is the monoacidic base. Now before only we discussed. So NaOH is the monoacidic base. So monoacidic base valency factor 1. That's why 2 into 1 equal to 2. 2 gram equivalent. So here H2SO4 equal to 2 gram equivalents. NaOH equal to 2 gram equivalents. That's why here we write 2 gram equivalent of H2SO4 equal to 2 gram equivalent of NaOH. So 1 gram equivalent of acid equal to 1 gram equivalent of base. How much heat energy release? Minus 57.2 kilojoules for equivalent or minus 13.7 kilocalories for equivalent. 2 means 1 gram equivalent equal to minus 57.2. 2 means 2 into minus 57.2. That's why your answer 2 into minus 57.2. That means 114 minus 114.4 kilojoules per equivalent or 2 into minus 13.7 equal to 20 minus 27.4 kilocalories equivalent. Like that you have to do problem. Simple problems only. Okay, simple problems only. So always what you doing? Equivalent of acid equal to equivalent of base. Then equivalent equal to number of moles into valence factor. Valency factor depend on acid means monobasic, dibasic, tribasic. Base means monoacidic, diacidic, triacidic. You should identify that one. That means you can easily find out the sum. Next. Next one are the sums we have to do to understand. Next sum. 36.5 grams of HCl neutralize with 40 grams of NaOH. Heat evolved is gram equivalent means number of moles. Direct shortcut write amma. Number of moles means n into valency factor. N into valency factor equal to number of moles into valency factor. Okay. Here number of moles of HCl only weight given amma. That's why again number of moles equal to weight by molecular mass. Here number of moles equal to weight by molecular mass. Already knows. That's why here HCl weight 36.5 by HCl molecular mass. Chlorine 35.5, hydrogen 1. So by 36.5 into HCl is monobasic acid. That's why valence factor 1 equal to 1. 1 gram equivalent of HCl. Next here number of moles of NaOH. How many grams? 40 grams. So weight 40 by NaOH molecular mass 23 plus 16 plus 1 40. Okay, into NaOH monoacidic base. That's why 1. That means here 1 gram equivalent of HCl equal to 1 gram equivalent of NaOH. Okay, finally we got 1 gram equivalent of given data. 1 gram equivalent of HCl equal to 1 gram equivalent of NaOH. Both undergoing to neutralized. That's why what is answer? So here 1 gram equivalent of HCl neutralized by 1 gram equivalent of NaOH according to data. So 1 gram equivalent means what is answer? Kilojoules means. So minus 57.2 kilojoules per equivalent answer, or minus 13.7 kilocalories per equivalent answer. This is the answer. Okay now. Next. Next one. Next question. 49 grams of H2SO4 neutralized by 40 grams of NaOH. 40 grams of NaOH. Heat evolved is right. Here gram equivalent of H2SO4 equal to 1 not needed. Just gram equivalent of H2SO4 equal to gram equivalent of NaOH. Here how many gram equivalents of H2SO4? How many gram equivalents of NaOH? We have to find out. Okay, again gram equivalent means number of moles into valency factor. Gram equivalent means number of moles into valency factor. Here also gram equivalent means number of moles into valency factor. Okay. For H2SO4 how many moles we have to find out? So H2SO4 weight they given 49 grams. 49 by number of moles means weight by molecular weight. 49 by H2SO4 molecular mass 98, 64, 96, Okay, here 1 by 2 into 2 equal to 1. Okay, 1 by 2 into 2 equal to 1. 1 gram equivalent. Here 1 gram equivalent of H2SO4. Here number of moles means weight by molecular weight. 40 by 40 NaOH mono acidic base. That's why equal to 1 gram equivalent. 1 gram equivalent of NaOH. So both here 1 gram equivalent of H2SO4 we have to get. Okay, that's why here both are 1 gram equivalent. 1 gram equivalent of acid with 1 gram equivalent of base neutralization means how much energy? So minus 57.2 kilojoules per equivalent or minus 13.7 kilocalories per equivalent. This is next problem. 20 same question. 24.5 grams of H2SO4 neutralized by 20 grams of NaOH. 20 grams of NaOH. Okay, heat evolved is we have to find out. So already we know gram equivalent of H2SO4 equal to gram equivalent of H2SO4 equal to gram equivalent of NaOH. Okay, again you know number of moles into valency factor, number of moles into valency factor equivalent equal to here number of moles H2SO4 24.5. Okay, 24.5 weight by molecular mass 98 into H2SO4 dibasic acid 2. Already we know so. Here 20 grams number of moles weight by molecular mass 20 by 40 into 1. That means here 4. That means here 1 by 2 gram equivalents come. Here 1 by 2 gram equivalents of H2SO4 coming here. Okay, here also 1 by 2. So here also 1 by 2 gram equivalent of NaOH come. Okay, 1 by 2 gram equivalent of H2SO4, 1 by 2 gram equivalent of NaOH. So here 1 gram equivalent equal to 1 gram equivalent of acid and base neutralized equal to minus 57.2 kilojoules per equivalent. Okay, 1 by 2 gram equivalent equal to how much? So cross multiplication, that means minus 57.2 by 2. Okay, almost 28.6 minus 28.6 kilojoules per equivalent. Same kilocalories also. 1 gram equivalent equal to minus 13.7 kilocalories. 1 by 2 gram equivalent equal to how much? So minus 13.7 by 2. Like that you have to doing. Okay. Next one. Next one, for example, 0.4 moles of 0.4 moles of H2SO4 neutralized with 0.4 moles of 0.4 moles of NaOH. NaOH. Heat evolved is. Heat evolved is. Heat evolved is. Okay. Already we know gram equivalent of H2SO4 equal to gram equivalent of NaOH. Gram equivalent of NaOH. Okay now. Gram equivalent means number of moles into valency factor. So here 0. Number of moles into valence factor dibasic acid 2 equal to 0.4 into 2. How much come on? 0.8. 8 gram equivalents. Okay, here same 0.4 into number of moles. Valence factor 1. That means 0.4 gram equivalents. Listen, already what we discussed, gram equivalent of acid equal to gram equivalent of base. Here acid 0.8, base 0.4. How to calculate? Whenever acid and base having two different gram equivalents, okay, less value we consider. Whenever acid and base having two different gram equivalents, we consider less number of gram equivalents. That's why here NaOH is less. This is more. That's why less only consider. Less gram equivalents only. Less gram equivalents only. Less gram equivalents only consider. That's why 0.4 only you taking value. So 1 gram equivalent equal to minus 13.7 kilocalories per equivalent. 0.4 gram equivalent equal to how much? That means minus 13.7 into 0.4 equal to answer. Okay, that means whenever acid and base having different gram equivalents, we have to consider least gram equivalent. That point is very important. Here, keep in box that point. Here, whenever acid and base to different gram equivalents, to acid and base different gram equivalents, okay, only consider least gram equivalents. Only consider least gram equivalents. This point is very important. Okay, if both are same gram equivalents means no problem. Okay, but whenever acid and base both different gram equivalence values, we have to consider least gram equivalent value only. So ignore more gram equivalence value. Remember that point, Amma. Okay. Next, yesterday question paper one question came, Amma.